We'll know when we are actually live on the streaming site.
Yes, I'll just check and let you.
Yes. Okay. I think we are
Yes,
live.
it has started.
Okay, great.
Okay.
All right.
Yes.
Okay, so you may start.
Right. Yeah. Professor Dr. Gurian sir, we are starting the webinar.
Okay.
Yeah. Good day, everyone. It's my privilege to welcome all of you for this special webinar commemorating the World Ocean Day. Today is a global occasion to recognize the ocean's immense role in sustaining life of our planet. This year, as we celebrate this ocean's wonder, we also acknowledge the pressing challenges it's facing: pollution, climate change, overexploitation, etc. And today's discussion mostly is grounded in the framework of United Nations Sustainable Development Goals, especially Goal 13 on climate action and Goal 14 on life below water, which calls for the conservation and sustainable use of our oceans, seas, and marine resources. Achieving these goals require scientific innovation, policy action, and community engagement, which brings us to our vital organization in India, that's our Ocean Society of India, or known as OSI. OSI has been playing a crucial role in advancing oceanography and marine research in India through its various initiatives. The present OSI president, Dr. Kurian, will be talking more on OSI and its activities. Through this webinar, we aim to inspire action, share knowledge, and foster collaboration in protecting our marine ecosystems. This OSI special webinar will be given by Dr. Helen Phillips from the University of Tasmania. OSI Pune chapter is leading this special webinar. Office bearers of Pune chapter, Dr. Aditi Deshpande, Dr. Supriya Chakrabarti, and their team will be taking over the further proceedings. Let's work together to safeguard our oceans, our planet's most precious resources, for ourselves and for the generations to come. Thank you and welcome once again. Over to Dr. Supriyo.
Good morning, everybody. I just like to give a brief introduction about the World Ocean Day. The World Ocean Day, celebrated annually on June 8, is a global movement aimed at fostering awareness and action toward ocean conservation. Officially recognized by the United Nations in 2008, this day highlights the critical role of oceans in regulating Earth's climate, supporting biodiversity, and sustaining countless livelihoods. The World Ocean Day serves as a powerful reminder of the responsibility and opportunities in ocean and climate science. Covering over 70% of our planet, the oceans are the heartbeat of our ecosystem, providing half the oxygen we breathe, regulating the climate, and supporting a vast array of marine life. Scientific advancements in oceanography, atmospheric sciences, and climate modeling depend on innovative research, interdisciplinary collaboration, and active engagement with policymakers and society. World Ocean Day is an opportunity to reflect on the importance of sustained research, ethical responsibility, and proactive engagement in addressing the most pressing ocean and climate challenges. By leveraging scientific expertise, collaborative networks, and outreach initiatives, the next generation of researchers can drive meaningful change. As we gather here today to commemorate World Ocean Day, let us take a moment to reflect on the vital role of our oceans play in sustaining life on Earth. Today, we come together to raise awareness about the importance of ocean conservation, to acknowledge the challenges our oceans face, and to celebrate the beauty and wonder of the underwater world. we recognize the impact of human activities on ocean health and commit to making a difference. Let us pledge to reduce our plastic footprint, to support sustainable fishing practices, and to protect marine habitats. Let us inspire others to join us in this crucial mission. As we begin this event, let the spirit of World Oceans Day guide us towards a future where our oceans thrive and our planet remains vibrant for generations to come. Thank you.
Thank you, Dr. Supriyo. I will request Dr. Kurian to give an introduction about the Ocean Society of India. Thank you.
Good day. Thank you, Dr. Aditi. Good day, everyone. Distinguished Speaker of the Day, Professor Helen Phillips, Professor Jayakumar, Vice President of OSI, Dr. Aditi Deshpande, Chairperson of OSI, Pune Chapter, Dr. Supriya Chakrabarti, Secretary of OSI Pune Chapter, my colleagues from the OSI, and other attendees. At the outset, let me congratulate the OSI Pune Chapter for organizing this webinar. I extend a warm welcome to all the participants of this webinar. My heartfelt greetings to the Speaker of the Day, Professor Helen Phillips. We are honored to have you here, Professor Phillips, to deliver a talk on a topic that is most relevant on the occasion of the World Oceans Day. I've been requested to give an introduction on Ocean Society of India. As you all know, OSI is the professional society of ocean scientists and technologists of the country. OSI is relatively young when compared to our counterparts in the rest of the world. In Australia itself, I think you have two associations, Australian Marine Sciences Association, Australian Meteorological and Oceanographic Society. We have the New Zealand Marine Sciences Society, Association of Marine Science, Limnology and Oceanography USA, Canadian Meteorological and Oceanographical Society. There are many like that, which are pretty well established. As I said, we are young. We made a humble beginning in 2006, but then it is growing significantly since then. I am proud to say that OSI has around 860 life members as on today, and it has 7 chapters covering the length and breadth of the country. The society provides avenues for robust technical dialogue across the disciplines of oceanography through conferences, webinars, and panel discussions to broaden communication and share new ideas. The society addresses a broad range of national and international oceanographic concerns, including marine pollution, global warming, and their effects on all aspects of life in the country. We have the biennial OSI conferences, which is called as OSICON, conducted since 2009 in premier institutions of the country. We have just recently conducted the OSICON 25 at the National Institute of Oceanography. Professor Jayakumar Sheelam and Dr. Mani Murali, they were the organizers, and this conference was a big success. Through its awards program, the society recognizes and celebrates our colleagues' exceptional achievements and contributions to ocean sciences. Honorary fellowship is the highest honor that the OSI provides. It is conferred every year on highly distinguished professionals of eminence. Next is the OSI fellowships that are awarded to life members of OSI for outstanding contributions to ocean science and engineering. The next category of awards is the endowment awards instituted in honor of eminent scientists. OSI has instituted 2 awards so far. The first one is the Dr. D. Srinivasan Endowment Award, instituted in loving memory of Dr. D. Srinivasan, former director of NPOL and one of the pioneers of naval ocean research in India. The next endowment award is in fond remembrance of Professor R. Ramesh, who was a distinguished scientist at the PRL in Ahmedabad, known for his significant contributions to climate and ocean sciences. There are a couple of endowment awards in the offing, which I am not mentioning right now. The society motivates students and young researchers for a career in oceanography through several of its awards and orientation programs. It awards best thesis awards in 7 themes of oceanography, ocean science and technology every 2 years. It awards PG dissertation awards every year in 7 themes of oceanography to master's students. Best paper awards are presented to young researchers for the best presentation in OSI conferences. Outreach programs are another important activity of OSI. The society organizes outreach programs on different aspects related to ocean conservation and sustainable use of ocean resources with the aim of inculcation of the message of a clean beach and pollution-free ocean in the minds of students and general public through educational programs, awareness campaigns, ocean conservation success stories, and good practices. OSI celebrates the World Oceans Day in a befitting way. In 2024, we had organized beach cleaning at 23 locations covering the whole coastline of the country. This year, we are doing in 21 locations. In addition to beach cleaning, we organize awareness seminars in different parts of the country for school and college students, members of coastal communities, NGOs, etc. The International Coastal Cleanup Day also is being celebrated with different activities. We have an in-house magazine, Ocean Digest, published quarterly. This magazine contains lead articles, short articles, announcements, and important other information that is required for the members of the OSI and the general public. With increasing membership and patronage from leading institutions, the OSI plans to play a dominant role in the development of ocean sciences and technology in the country. These include playing a pivotal role in the development of human resources in the field, sensitizing school children on ocean sciences, conducting training programs for policymakers and engineers to alleviate the knowledge gap, sensitizing the local community in creating a litter-free coastal coast through tie-up with coastal NGOs, etc. That's all in a nutshell that I have to tell about the OSA. Thank you all for the patient listening. Let us all listen to the motivating speech of Professor Helen Phillips on the occasion of the World Oceans Day 2025. Thank you.
Thank you, Dr. Kurian, for that wonderful introduction to Ocean Society of India. We'll have a brief description of the activities conducted by OSI Pune chapter given by Dr. Supriya Chakravarti. Sir, you are on mute. Can you unmute?
Thank you, Aditi, for giving me this opportunity. I just like to give you a brief introductions about the activities of the OSI Pune chapter. The OSI Pune chapter is an integral component of the OSI. The members of the Pune chapter are actively engaged in various outreach programs to popularize the awareness on ocean. It regularly arranges webinars and lectures by eminent scientists, occasionally in association with other professional bodies such as the IMS Pune chapter. Some of the recent programs are on 15 March 23, the OSI Pune chapter collaborated with IITM to co-host a workshop on the role of women in weather and climate science in Pune. The workshop honored Dr. P. Salvekar, a distinguished former scientist at IITM, for her remarkable achievements in ocean science. On March 23, 2023, the OSI Pune chapter celebrated World Meteorological Day by organizing a half-day workshop in collaboration with the Department of...
Supriya, sir?
Yes. Can you hear me?
Is someone's YouTube on in the background?
It's not in my YouTube.
Rama will be playing YouTube. Something wrong?
Something wrong?
My YouTube is off.
Supriya, sir, please wait. Please wait.
Okay.
Yes, I request you to please switch off YouTube.
Okay.
Someone's, I think, sir. Okay. I don't know, is YouTube on somewhere because I can hear myself.
We can hear everything clearly, Rajni.
Okay, fine.
Okay.
So should I continue?
Yes, sir. Please continue.
Okay. On March 23, 2023, the OSI Pune chapter celebrated World Meteorological Day by organizing a half-day workshop in collaboration with the Department of Atmospheric and Space Sciences at Savitribai Phule Pune University. The event was held at the DAS Seminar Hall. The event was featured by Professor Anand Karipot, Head of Department of Atmospheric and Space Sciences, as the chief guest, and he spoke about the significance of World Meteorological Day. On October 18, 2024, the OSI Pune chapter co-hosted the annual monsoon workshop in association with the Indian Meteorological Society at the Namdev Hall, Savitribai Phule Pune University. The Pune chapter introduced a quarterly newsletter, Ocean Digest, in a bid to popularize the ocean science to the common people. The OSI members, especially the scientists from IIT and Pune University, regularly contribute in this newsletter. The OSI Pune chapter members actively contributed to various initiatives of the present body, including serving as election officers for the GC committee elections spanning the successive terms of 2023-25 and 2025 and 27. Additionally, they played a key role in moderating the PG Dissertation Award for 2024 and facilitating the commissioning of the Professor R. Ramesh Endowment Award, which recognizes excellence in the field of ocean and climate sciences. The OSI Pune chapter welcomes anyone who is interested in learning more about the ocean and its resources. Thank you.
Thank you, Dr. Supriyo. So it's my honor to introduce our speaker for today. Professor Helen Phillips is a professor of physical oceanography at the Institute for Marine and Antarctic Studies at University of Tasmania. She leads the Center for Oceans, Ice and Climate within IMAS and is a chief investigator in the Australian Center for Excellence in Antarctic Science, the Australian Antarctic Program Partnership, and the Australian National Environmental Science Program Climate Systems Hub. Helen's research focuses on the ocean currents and the small-scale processes that help the ocean absorb and distribute heat and other properties. She combines observations from research vessels, robot profiling floats, and satellites with ocean computer models to investigate these processes in the Indian and the Southern Ocean. Helen leads a vibrant team of students and postdoctoral researchers and collaborates with researchers around the world to answer urgent questions on the ocean's role in the climate system. It is wonderful to have you, Dr. Helen. You may please share your screen and begin your talk. Thank you so much. May I request all the members present in the meeting to make sure that your mics are muted so that the speaker is not interrupted. Thank you so much.
Thank you very much, Diti, and for the very warm welcome. I think we're not yet seeing my screen. Is that right?
No, we can see your screen.
But it's just in the.
Yeah.
Yes. You need
It's
to
in
put it on
the
show mode. You have to put
Yeah,
it
it's
on
not in the
show mode.
slideshow mode yet.
Okay.
Yes.
For some reason, it's gone to a pencil. That's just.
Maybe you can ask it to allow. I think I see a.
Yes,
Yeah.
I've done that. I've done that.
No, not you. Yes, done.
Oh, yeah. Done.
Okay.
Very good. I think that's clear now.
Yes, totally. Thank you.
So, yes, thank you very much for the invitation to come and speak today on World Ocean Day to your Ocean Society of India Pune chapter. It is my great honor to be here and to meet many of you. We have some alumni from Pune here, amongst our PhD students, and they are a real asset to our research and activities here. This photograph here is standing in front of our national research vessel, the RV Investigator. And this is the ship on which we've done a lot of our research measurements. But as Aditi mentioned, we also use the Global Observing System, and there's a lot of rich data to work with. So I wanted to talk today a little bit about our oceans health crisis. I think this will be familiar to most of you. And I like the health analogy. So as ocean scientists, we have been diagnosing the state of the ocean and the changes within it for some very long time. And we understand the problems, and we need to move to a cure. And of course, progress has been being made towards that for some time, but I think I would like to step through my thoughts on this idea of from diagnosis to cure. Now, I've prepared the talk with a general audience in mind, and I know that some of you know more about some of the aspects I'll discuss than I do. And so I hope that that this will be the right level to pitch at for a general audience. So World Oceans Day this year has the theme of wonder, sustaining what sustains us. And I read quite a bit on the UN World Oceans Day website, and what struck me most keenly was this small quote that the act of wondering serves to remind us that we are part of something bigger. And in the photograph, there's something very tiny there, just a remarkable creature on our planet that lives in our ocean, and we are part of the same world. So I think being inspired about the wonderful things in the ocean helps us move forward in our lives with the interests of the planet at heart. So as you well know, the ocean covers more than 71% of the Earth's surface. It provides oxygen, food, habitat for the amazing marine life, fresh water, livelihoods, and cultural significance. And World Ocean Day is a call to not lose sight of the ocean's wonder. So although the ocean is supporting many of these benefits to our world, my focus today for this talk is really on the ocean as a physical system, coming from my background as a physical oceanographer. So while there's a lot to say about the marine life, the habitat, the livelihoods that it supports, and oxygen and freshwater cycles, I won't really go there today at all. I will stick with the physical oceanography, and I hope that this will be of interest to you. I'd like to start with ocean circulation, which is what I find absolutely amazing or wondrous. And this incredible animation has been developed by NASA some years ago, and I just like to play it. It only goes for a few minutes. So what you're seeing here are particles moving through an ocean numerical model. And because of the rate of movement, you can see the strongest current pathway. Here we see the Gulf Stream emerging from the Gulf of Mexico go and move across land. And the circular features are ocean eddies. So this animation moves around the planet and it's kept very fine. Here we move to the Indian Ocean, the Agulhas Current and eddies moving north through the Somali Current and up to the Arabian Sea and Bay of Bengal. The Indonesian through flow here is the pathway from the Pacific to the Indian Ocean. And then we move to the North Pacific Ocean. Kuroshio extension and very strong eddy, very. Back to the equator, we see strong pulses of current and again more eddies. And then down to the Southern Ocean, where the Antarctic circumpolar current flows all the way around Antarctica, also with a rich eddy field that is responsible for moving heat southward towards Antarctica. My home, Tasmania, with East Australia current coming south on the east coast and Bruin current coming south with many eddies on the west. And here's the coast. I think I might have told you incorrect. So I was explaining the currents and I wasn't sure if my voice was legible over the top of the music, but perhaps it was. So this was produced by NASA, and I find it fascinating to watch it over and over again, to see that horizontal circulation of the ocean and the variability that is so important, not only for the physics of the ocean, but for the biogeochemistry and the ecosystems that benefit from that stirring of the ocean. So in addition to the horizontal circulation, there's a vertical circulation that extends throughout the entire global ocean. So the ocean's global meridional overturning circulation is a pathway from the surface ocean to the very deepest layer in the ocean. And shown here are the different current pathways. So the red lines are the surface flow, the warm water movement. And if we follow from the Indian Ocean, the Pacific Ocean feeds warm waters through the Indonesian seas that find their way down the Agulhas and up into the South Atlantic and then the North Atlantic Ocean, and eventually up into the Arctic. And in the Arctic, in the Greenland, Norwegian seas and the Labrador seas, dense water is formed that allows these warm surface waters to sink very deep into the ocean interior. And that's what's indicated here by the white circle. And you can see the pathway changes from red to white. And those white pathways are denser water that travel from the north southward, continuing the overturning circulation and supplying the deep levels of the Antarctic circumpolar current. There is the pattern of the winds lead to upwelling throughout the Southern Ocean, marked by these yellow circles. So those deep waters find their way back to the sea surface around the Southern Ocean. And the red dots throughout the tropics and subtropics indicate other regions of upwelling, but this is by mixing and transformation of water masses from dense to light, rather than the wind-driven upwelling that we see in the Southern Ocean. Around the Ross Sea and Weddell Sea and some other parts of Antarctica, we also see deep water formation. And here the strong heat loss to the atmosphere and the extrusion of brine into the seawater makes very dense waters that are the densest in the world, and they sink down to the bottom of the ocean as Antarctic bottom water. And those bottom waters follow the seafloor northwards out of the Southern Ocean and provide oxygen to and warmth to other parts of the world. So this vertical overturning is the means by which oxygen from the surface of the ocean and heat and carbon finds its way deep into the interior of the ocean, and is what allows the ocean to be such an incredible absorber of all of the important gases and energy. So how do we see below the ocean surface? If we look out at the ocean, it's very hard to penetrate the surface without some very considerable effort. And the Global Ocean Observing System has built up a suite of tools by which the ocean can be observed, or the physical and some biogeochemical properties of the ocean. So from a research vessel, we can lower instruments through the water column down to the sea floor. This is a CTD rosette that has bottles around the outside that can capture samples of the water at different depths. And inside the center of the rosette are electronic instruments that are measuring temperature and salinity, dissolved oxygen, fluorescence, sometimes nitrate, and many other geochemical properties can be determined from the water samples that come back onto the ship. There are also instruments moored to the sea floor that have a line extending up to the sea surface that carry instruments through the water column, and these often record for many years. So while a research vessel is only out in the ocean for a month, maybe longer, the moorings can stay in the ocean for 1 year or 2 years, and they can be refreshed with new equipment and set to record again for another period of time. Some moorings have surface instruments like this, which can measure atmospheric properties and also transmit to satellite. Some moorings are below the sea surface and can only be recovered by a research vessel going back to collect them. In the Southern Ocean, there are many seals that have instruments on their forehead. They have CTD sensors and measuring temperature, salinity, and pressure, and some have other sensors for biogeochemical properties. And because the seals dive deeply, they can give us incredibly important information in regions where we have trouble taking ships and other instruments. And that's particularly in the polar regions, where the seals are happy to work around the ice, dive beneath it, come back up and find a gap where they can transmit to satellite and take a breath. And so they are a really important part of our measurement program in the polar regions. And it doesn't bother them. We have marine biologists who are very sensitive to the comfort of the seals, and these instruments are shed once a year when the animals molt on the island, and then the data can be recovered. The information also helps to understand the changing ecosystem that the seals are working in and monitor the health of the animals. And there are other subsea instruments like these gliding instruments that can be controlled autonomously to bring back data. But I'd like to highlight the Argo profiling floats, which have really revolutionized the way we observe the ocean because they cover the entire global ocean, and I'll show you more about that soon. And another important feature is that some vessels who are not research vessels also make observations for the global observing system, and they contribute a valuable collection of data. And of course, tide gauges around the land and a complex connection with satellite systems that are monitoring the Earth. So a quick step into the Argo profiling float array. On the left are the locations of the floats that we're reporting in March 2025. At the moment, there are more than 4,000 operational floats. And the colours here indicate the country of origin of these floats. And so around India, we can see the Indian Oceanographic Program has many floats monitoring the conditions of the Arabian Sea and the Bay of Bengal. Around Australia, we have these pink floats that are in the Indian and Pacific, but also the Southern Ocean, and they are constantly being moved around by the ocean current, so they never stay exactly where you put them. One thing I'd like to highlight is the number of dark green dots, which is the USA, and they have been the backbone of the ocean observing system for many years, and we hope that these vital observing systems will continue into the future, and that other countries will bring more resources to maintain this very important monitoring system. Just a quick note about how these profiling floats work. They operate on a 10-day cycle. They start by sinking from the sea surface down to 1,000 meters, where they drift for about 9 days. And in drifting at 1,000 meters, we learn about the currents at that deeper level. At the end of 9 days, they sink down to 2,000 meters, where they begin an ascent to the sea surface, measuring temperature, salinity, and pressure as they go. Once they reach the sea surface, they transmit to satellite, so the data return is in real time, and the data is transmitted to the satellite and then down to a land station. The mission of the floats can also be updated because there's two-way communication between the satellite and the float. You'll note that there's a note here about a 6,000 meter descent. There is a new type of Argo float called Deep Argo that can reach to the seafloor, and that distance between 2,000 meters depth and 6,000 meters has been a real blind spot in our ability to observe the ocean, and so the beginning of Deep Argo is starting to reveal a great deal of very valuable information about the abyssal ocean. On the bottom right, I've just shown the lines that have been covered by research vessels over decades, and these repeat lines are visited maybe between every 3 and 10 years. The green lines are the repeat lines that have been completed recently, and the blue and red are still in the planning stage. So although this is an incredibly comprehensive network of observations of the full depth ocean, these extend to the seafloor everywhere, and they bring back not only temperature and salinity, but also biogeochemical and biological information that adds incredible value. But they are sparse and they are infrequent, and so Argo really fills the gap between what we can do from research vessels and what we actually need to know to be able to monitor the ocean and reliably track the Earth's energy balance. As well as observations, we also have numerical models, and I benefit from using numerical models, but I rely on my clever colleagues to actually create the ocean models. So on the left is an example of output from the Geophysical Fluid Dynamics Laboratory coupled model, and it shows sea surface temperature in February. So there's some really interesting patterns there. You see how the eddies stir the gradients of temperature throughout the ocean as the currents are moving around. And yes, I won't say any more about that, but on the right is a schematic of all of the different processes that are built into these global ocean models, making them an incredibly impressive representation of the physics of the ocean. So they have exchange with the atmosphere of energy and evaporation and precipitation, exchange with the ice and with the land. And so there are many different terms shown here. There's also geothermal heating that enters that brings heat into the internal ocean. There's internal mixing, eddy mixing, and there's also biogeochemistry. So they're incredibly complex and extremely physically realistic at high resolution. And so the beauty of the models is that they can produce a three-dimensional field of the ocean at any time. And so we can have a full view of the three-dimensional structure of the features that we might observe with Argo or with ship-based measurements that are perhaps at one particular time or in one particular location. And so the models help build that spatial and temporal context around the observations we make. So observations and models are critical partners in how we build our understanding of the ocean. So this is very simplified view of the Earth's energy balance, and it illustrates very well that ultimately all the energy on Earth comes from the sun, and the sun's energy is what drives the atmospheric circulation and the oceanic circulation. And so it's nice to step back to that fundamental view briefly. So of the incoming solar radiation, 100%, around 30% is reflected by the atmosphere and clouds and the Earth's surface back into space. Some other fraction is absorbed by the atmosphere and by the air, and around 50% reaches the surface of the Earth to be absorbed by the land and the oceans. And the land and the oceans have a temperature that's that causes them to emit long wave radiation. And so that's what's shown in the red pathway here. It's the long wave radiation, that's heat released by the Earth's surface and moves back into the atmosphere and some out to space. So 50% is absorbed by the land and the oceans, and as we saw, the ocean surface is 70% of the Earth's surface. So a bulk of that amount will be going into the ocean. And the result of that is the temperature distribution in the ocean. This is a climatology, so an average sea surface temperature from the Pathfinder satellite mission with a 4-kilometre resolution. And it shows very clearly that the tropics are much warmer than the poles. And the reasons for that are in part because over the equator and the tropics, the sun is directly overhead, so the ocean can't reflect as much heat as the polar regions. Because of the Earth's surface, the poles are the sun reaches the surface of the Earth at a low angle that allows it to be easily reflected. The other reason is that the poles have ice cover, which has incredibly high albedo and reflects also a lot of heat back away from the surface. So to maintain a balance, the ocean and the atmosphere have to move heat from the tropics to the poles, and the global overturning circulation is partly how the ocean achieves this circulation to maintain a steady balance on Earth and not allow the tropics to boil and not allow the Southern Ocean to freeze excessively. So what we've been talking about is a steady state balance, but now because of the increasing amounts of carbon dioxide and other greenhouse gases in the atmosphere, the Earth's energy balance is no longer in balance. It's an Earth's energy imbalance. So on the left is the natural greenhouse effect, where the sun's energy reaches the Earth's surface. There's some blanketing of the Earth by the atmosphere to retain enough heat that we have a comfortable life. But in the in our greenhouse warmed world, the atmosphere has many more gases, aerosols, and carbon dioxide and other greenhouse gases that are retaining more heat on the planet. And so the less heat escapes into space, and the Earth's atmosphere, land, and ocean are warming up. So we have a wonderful framework by which to monitor the changes on our planet. This is the Intergovernmental Panel on Climate Change. And it was established in the it has a history dating back to the 1970s and 1980s. But the IPCC itself was jointly established by the World Meteorological Organization and the United Nations. Now I'm forgetting what the EP stands for. Please forgive me, the UNEP. It was established in 1988. And following that have been the series of assessment reports explaining the state of the climate system based on all of the scientific literature available, synthesized by a group of experts who bring together this consensus view of the state of the climate system. And before the IPCC reports can be ratified, they have to be endorsed by international governments. And so there's a very detailed and careful negotiation between the scientists who understand the science and the governments who need to accept the advice from science and translate it into policy to give to their governments. And so each of these reports represents a consensus view, not only of scientists, but of the governments around the world who participated in this process. And the most recent report was the 6th assessment report, with parts of the reports published between 2021 and 2023. And in 2019, there were also a couple of special reports, which I'll refer to. And in 2007, the IPCC were jointly awarded the Nobel Peace Prize, which is a wonderful recognition of the work that they do. So what does the IPCC tell us about the changes in the climate system? So from the 6th assessment report, it tells us that the human influence has warmed the climate at a rate that's unprecedented in at least the last 2,000 years. On the left, I show the changes in global surface temperature relative to 1850 to 1900. So let's step through that carefully. On the lower axis is the year from year one to 2020, so the last 2000 years or more. And the vertical axis is the change in temperature since 1850 to 1900. The black line shows the observed measurements from our modern instrumental record, and the more dark grey line shows the reconstruction from proxy records and models that track very well the observations in recent times and give us confidence that looking back through the geological history recorded in ice cores, in corals, in tree rings, show that the temperature change on Earth has been extremely steady until very recent times. This extra little part on the left is looking at the warmest multi-century period in the last 100,000 years, and this is the range that we are told is what represents that warmest period. And here we are in our modern instrumental record, where the accuracy of the measurements are incredibly high and showing that the warming we're experiencing now is unprecedented. Now, if we look at the human influence side of the story, again, we have time on the lower axis from 1850 to 2020 and temperature change in degrees Celsius on the vertical axis. When we plot the observed record, that's what's shown in black here. It shows this upward acceleration in warming in recent decades. The brown line is the simulation from numerical climate models that recognize the increasing levels of greenhouse gases in the atmosphere. And you can see that that brown line tracks very closely what we've observed in the instrumental period. The green line shows the change in temperature of the Earth with only natural variability, so only solar and volcanic variability and no increase in greenhouse gas in the atmosphere. And you can see that that cannot explain the recent warming. And so that tells us that it is the change in the composition of the atmosphere due to the increasing levels of CO2 and other gases that has been responsible. And that undeniably points to humans as the cause of these changes. If we think about the ocean now, I'd like to explain the view that global warming is really ocean warming. And so essentially more than 90% of the increased heat on our planet has been stored in the ocean. If we look at this time series of increased energy held in the climate system, we can see it decomposed into the different parts of the climate system. The blue colours are the ocean in different layers, from the surface to 700 metres, 700 to 2,000 metres, and deeper than 2,000 metres. And so these full depth ocean, which has been warming and increasing its heat content, explains most of the change in energy that's been observed. The other components are the ice. So this grey line represents the absorption of heat by the change in phase of the Earth's ice. So glaciers and mountain glaciers and polar ice melt. warming of the land is in orange and the warming of the atmosphere is in red. So predominantly all of the energy from global warming has gone into the ocean. And that's these arrows point to the ocean parts and the cryosphere. If we think about the changes in terms of the global sea level, though, the story is a little bit different. The global sea level has changed both due to the expansion of the ocean because it's now warmer. Warmer ocean has a greater volume, and so the ocean warming has led to sea level rise. That's shown here in the ocean blue colours. But that's a smaller fraction of the total change in sea level, because now the fresh water that's been released from glaciers, from Greenland and from Antarctica are a major component of the change in global mean sea level. Land water storage is also part of the story. So we've gone from seeing 3% of the energy accounted for in the cryosphere to more than 50% of the sea level change due to the melt of land ice. So what is the effect on the temperature of the ocean? And we can see here ocean warming since 2004. And the point of 2004 is that that's when the Argo profiling float array began. And that's when we had global measurements of the ocean's heat content. So from 2004, the ocean was considerably cooler, and it's transitioned from a negative temperature anomaly here through the reference period around 2014 and into a warming period. So the surface ocean has become warmer, but also the warming has extended through deeper levels. We now see ocean warming at all levels of the ocean, particularly in the abyssal ocean, where those deep water formation regions carry heat directly to the sea floor. On the right is a profile of the global average trend in warming, and so it's the trend in degrees C per decade, reaching about 0.2 in the sea surface and decreasing with depth. This is another view of the influence of ocean versus ice melt on sea level rise. So from Argo, we can see the sea level change that's due to the ocean expansion, not only from warming, but also due to changes in the freshwater content of the ocean, because fresher water is less dense than salty water, and so it has a larger volume. And then the blue line shows what is observed from satellite as far as global mean sea level. And the difference between these two is the change in sea level due to the melt of land ice and the polar regions. We've been talking about global averages, but in fact, there are really complex regional trends in sea level rise, which we see here. So on the left is the total global mean sea level rise, the total sea level rise based on satellite altimetry, with the darkest regions in red being around 15 millimeters per year. But we can also see declines in sea level, and there are many questions to be answered about this distribution of the sea level rise. So in around India, we're seeing around 5 millimeters per year, but of course this is a coarse image, and there's a lot more detail when we look closer. The alternating blue and red patterns in the Southern Ocean around the Gulf Stream and Kuroshio are ocean eddies. So eddies move temperature around. They can take a parcel of warm water into a cold water region and vice versa. And so those warm eddies will show a higher sea level than the cold eddies, leading to this noisy pattern, but that's actual physical variability. When we look on the right, this is the part of sea level that's only due to the ocean change, and it has a similar pattern to the total sea level, but it's not as intense. The summary here is from the special report on ocean and cryosphere in a changing climate, and it's a very nice illustration of the not so nice changes in the ocean. In the ocean, we see an increase in ocean heat content everywhere, a decrease in pH, changing the acidity of the ocean, and a decrease in global oxygen levels. These are associated with sea level rise and more frequent marine heat waves. Changes in the ice, we're seeing a decline in Arctic sea ice, in glacier mass loss, and in snow cover. The Antarctic sea level change has also declined. There's a loss of mass from the Antarctic and Greenland ice sheets. And we've also recently seen dramatic loss of sea ice around Antarctica. So these are very sobering messages around widespread and serious change in the ocean. These changes in the physical climate system and the physical ocean obviously have impacts for the life within the ocean. And this summary highlights very clearly the threats to the different types of ecosystems around the world's ocean. If we just look at the arrangement of the figure, so here there's a level of impact or risk, and dark is very high risk down to virtually undetectable in white. And there's a confidence level around each estimate. So very high confidence in the IPCC language for things that are very well understood, and low confidence for things that are perhaps yet to be investigated thoroughly. And so warm water corals are the most vulnerable parts of the system, and the threshold to impacts and risks has been coming since well before the global average temperature was reaching 1 degree C. So global mean sea surface temperature relative to pre-industrial levels is what's shown here on the vertical axis, from up to 4 degrees Celsius. So we're sitting around 1.2 by many estimates at the moment, and you can see that warm water corals are very much in the very high risk category, and we understand that from reports of bleaching of coral that is all too frequent and all too widespread. And the work breaks down many other systems like kelp forests, seagrasses, all the way through to deep sea benthos. And these have varying levels of confidence in the assessment and varying levels of threat. So some of them are yet to be impacted by warming ocean temperatures. A surprising one is in fact the deep sea benthos. So you would think that in the deep sea there would be some insulation from warming temperatures in the upper ocean, but in fact These benthos are impacted by the declines in the ecosystems in the surface waters, so they often rely on the raining down of detritus from the upper ocean, from other species, and so that's part of the story around why the deep sea benthos might start to be affected as we approach 2 degrees of warming and beyond. So where are we tracking now in global fossil CO2 emissions? So CO2 is the perhaps biggest greenhouse gas that we worried about due to fossil fuel burning and land use change primarily. But there are, of course, other greenhouse gases such as methane and others. But for CO2, this is a history from 1960 through to 2024. And it shows a steady increase with some dips related to various financial disasters like the first and second oil crises, the dissolution of the Soviet Union, the global financial crisis, and the COVID-19 pandemics. But on each occasion, these dips in the CO2 emissions, cumulative CO2 emissions, has been temporary, and the years following we've recovered. So now we're at the highest level of CO2 in the atmosphere since measurements began, and 2024 accounted for an increase of 10.2 gigatons of carbon. I would like to read a plateauing of that curve right here, but I think we have to wait for the data to come in. I'd like to point you to the Global Carbon Project because they have so much incredible information that allows you to dissect this global average curve into the origin by country, the origin by source, and it's just a really interesting set of data to step through that's been brought together by the scientists who've formed this Global Carbon Project. So from the IPCC, the challenge that comes through is that we need to cut emissions quickly and sharply to bring the CO2 emissions to zero and create a safer and sustainable world. We need to scale up practices and infrastructure, or let's say systems, that enhance resilience for our planet. They advise a cut in global greenhouse gas emissions by nearly half by 2030. So there's some work to do there, and action is required along many dimensions. The synthesis report is a compressed version of all of the work put together in the 6th assessment report, and if you have some spare time, that's a very, very interesting read. So the hope they put forward, the IPCC, is that by mainstreaming effective and equitable climate action now, we'll reduce losses and damages for nature and people. Climate action provides co-benefits in terms of community cohesion and increasing resilience of the world's populations. There are already multiple feasible and effective options available to reduce greenhouse gas emissions and adapt to human-caused climate change. And the hope is that we will seize upon these and expand their use to make rapid change. So I think there is a lot of cause for hope, and a wonderful place to look for this is in our World in Data. So I've given the website here. They have many different analyses of global data, and here is some information around the change in per capita carbon dioxide emissions for some example countries, and the relationship with the global domestic, the global domestic product. So essentially the wealth of the country versus its CO2 emissions. And for many years, these were intimately coupled. So increasing CO2 emissions translated into increasing wealth for the country. But since around the 1990s, there's been a separation in these curves. And so here in dark blue is the global domestic product of the United Kingdom with a steady increase, a few dips, but generally increasing, while the CO2 emissions per capita of that country have made a dramatic decline, a steady decline, I should say. And the red line is a component of the CO2 emissions per capita that's due to consumption. But I would have to look more carefully to be able to tell you exactly what that one means. So let's just focus on the dark blue for the wealth of the country and the lighter blue for CO2 emissions. And you can see that for these other countries, France, Germany, Sweden, United States, and Finland, this decoupling of the carbon dioxide emissions and the wealth of the country has been in place for some decades now. So we no longer need to say we can't reduce emissions because it will threaten the wealth of our country. That's just not true anymore. Another interesting piece of information is the rapid increase in renewable energy around the world and the decline in the energy that we get from fossil fuels, including coal, oil, and gas. Nuclear is another curve on the graph, and that's showing some decline, which renewables have offset. Increase in renewables has offset, as well as taking up a lot of the energy requirement that was formerly delivered by fossil fuels. So I think that's a cause for hope. And I think the renewable energy market is expanding, and we can look forward to a continuation of this upward lift in the curve and hopefully an increase in its rate. So what we've talked about are global impacts and global systems, but we come back to us as individuals and communities, and we always want to know, what can we do? And there are so many new books I've been seeing around that offer hope and advice and really try to provide pathways for individuals to help shift the system to a more sustainable state more rapidly. And I was particularly interested in this book, 5 Times Faster by Simon Sharp. And the message he gives is that being part of the solution is not about your carbon footprint. And he makes the case that actually the fossil fuel industry has a lot to answer for, both in denying climate change, but also in pushing responsibility back onto individuals. And of course, we all live on this planet, we all consume, we all are responsible for emissions, and we can certainly do our best to reduce them. But in fact, what we need is systemic change. And so the other thing that Simon Sharp talks about is, as well as looking after our household, reducing our waste, recycling what we can, minimizing waste as broadly as possible, the best impact we can have is by identifying what is our point of leverage. So by that he means, what can you do better than most can do to bring about system change? What's your key attribute that could allow you to help others shift more rapidly to a sustainable way of living on our planet. And examples are, as teachers, we can share information about our planet and promote others to also be part of the solution by joining societies, by sharing knowledge. An engineer might apply themselves to building more sustainable or more efficient instruments or batteries that are able to store energy more densely, and so on. So we each have talents, we each have a network, and so the challenge is to identify our point of leverage and help to spread this shift towards a sustainable planet more rapidly. Another thing that has become incredibly apparent in recent times is that the information about our world is often dominated by media outlets that have a vested interest in telling a particular story. And so independent journalism is incredibly valuable for revealing the truth about a story. And so supporting independent journalism through subscriptions and helping the population of our planet access reliable and non-biased information is crucially important in these times. So I think here's a little summary. What can I do? Do the most with the least. And sometimes this can just be as simple as preparing food in our homes. Around 26% of Earth's greenhouse gas emissions is associated with the production of food, and 6% of those emissions are from food waste. So if we can all contribute to using our food without waste and helping find pathways for food that might be lost to waste to reach those who need to eat it, would be incredibly helpful. I was privileged to attend a presentation by our Student Union Association, and they have been working with food producers in our local region to save good food that would have gone to waste and bring it to students in our university who are suffering from food insecurity. They don't have enough money to know that they'll get their next meal reliably, and so the redirection of this very good food to feed these students is a great outcome and saving many thousands of tons of food from going to landfill. I think if we include the ocean and the earth in every decision we make, like if we need a new appliance, make sure it's the most efficient, most energy efficient appliance that we can afford, for example. Voting for leaders who will drive system change is a very powerful way that we can contribute to the change for the better. In a democracy, we can vote for leaders who stand up for moving towards a transition in our energy system and waste systems, and so prioritizing that is very important. But finishing on the point of that I raised earlier about finding my point of leverage to help bring change. So that's a challenge for all of us to try to figure that out. So I'd like to finish now and thank you for coming to hear my talk, and thank you for your support for World Oceans Day. And please take the time to have a look at the information on the World Oceans Day website. Thank you very much.
Thank you so much, Ellen. I love the entire outlay of your talk because it covered a lot of issues which are very relevant today and how we tackle the climate crisis, especially as academics. So if there are any questions, we can start from the members who are present in the meeting. You can either raise your hand or unmute yourself and we'll take your question.
Meanwhile, Rama is looking at the YouTube questions, right?
Yeah, she is. I believe one of our students.
Bilva has a question. Bilva
Yeah, Bilva, go ahead.
Hi, am I
Bilva,
audible?
can you switch on your camera also? It'll be nice to see you.
I can't switch on my camera, but I have a question.
Sure, go ahead.
Firstly, thank you so much for the talk. It was really interesting. I have a couple of questions. I read that you're working on currents and ocean heat distribution. So I wanted to know if there are any studies or if you have observed any small scale variations or changes in ACC because of extreme and severe heat waves occurring near the Southern Ocean?
Yes. So the ACC region is warming like most of the ocean, and I don't track heat waves myself, but there are certainly, from maps of sea surface temperature, you can see the occurrence of warm periods in the Southern Ocean and the ACC region. So yes, global studies of marine heat waves are also finding this in the Southern Ocean. So yes, does that answer your question?
Yeah. Thank you. And another question would be that it was really nice to hear about cold water corals because there's a lot of literature about warm water corals, but personally, honestly, I did not know about cold water corals until very recently. So I wanted to know if you have any idea about how different they are from the warm water corals.
No, that's not my area of expertise, but only to say that they're adapted for the subtropical and waters and further south rather than the tropical environment of the warm water corals. But I would suggest you could start with the special report on oceans and cryosphere in a changing climate, the IPCC SROC report, and that will have references to studies looking into the cold water corals that you could investigate.
If I can help, Helen, a little that I've worked on long ago. Cold water corals do not have symbiotic algae in them, and because of that, they can survive below the photic zone. And that's why even in the deep water, they can survive where there's cold water, and many of them, and they are also solitary. They don't build reefs like we have in shallow waters. So one, they're not dependent on photosynthesis for their survival. That's the major change between cold water corals and warm water corals.
Oh, thank you very much. I've learned something.
Thank you so much.
Okay. Anyone else in the audience? We have actually, yes, someone spoke.
Yeah, I like to have ask
Yes,
a
sure,
question.
sir. Please go ahead.
Firstly, I congratulate Helen for giving a very nice, lucid talk on oceanography. It's a very nice talk, and I think students have gained a lot. I just like to have a simple question. As you said that the ocean warming, it has two components. One is by expansion, another is by the melting of glaciers and polar ice. And how these rates change with time? And do they remain more or less same, or and what are their relative roles? Do they change, especially in the context of warming? What we can expect in the future?
Mm. So yes, the rates have changed. When we first were able to detect sea level rise, largely that was due to the ocean expansion, and as the warming atmosphere and the encroachment of warm water on polar ice has become greater, the rates of ice melt has increased. So we can see that in the rates of mass loss detected by satellite measurements. And so the papers that I've seen show an acceleration of the loss of mass around Antarctica and in glacial regions. And so that contribution that's due to the ocean and due to melting ice has become much more weighted towards the role of the freshwater input by melting ice. And I think that we'll see that increase further.
I have a question.
Thank you.
Aditi, I have a question. Helen, you just showed that since about year 2000, we see a decoupling between the GDP of countries and the carbon footprint or the carbon emissions, right? Uh, could you explain, is it attributable only to renewable energy? Apart from that, there are recent reports which say that more automation, more mechanization, AI is leading to increase in carbon emissions. And then how do we explain this decoupling with increase in automation and such sources?
That's a wonderful question, and I really wish that I had studied it more on the World in Data website. There's a lovely book written by one of the analysts from that organization, and she talks about this in her book. And the book is called Not the End of the World, and she draws on all of the information from our World in Data to explain exactly that. Why is the well, many things, but that particular question, why has the decoupling been able to occur? And I apologize for not having read that chapter.
It's okay. It's okay. At least I'm going to look at this book that you said.
Yes. I have
Yeah,
a copy.
I'm always excited when speakers share whatever book they find interesting because it always adds to our knowledge. So, do we have any more questions from the people present in the meeting? If not, then there's a question which was posted on YouTube. It's actually from Nagraj Adve, who is the founder of this group called Teachers Against Climate Crisis. So it's a group of academics who are working in STEM as well as economics, social sciences, who are all geared to, working in the area of climate change and how to address the issues that are coming across. So he has asked, how do teleconnections work? What do they in terms of ocean currents, what do they transport or connect, and what role do the oceans have in teleconnections?
So the oceans connect the world globally. So the overturning circulations can carry signals from, say, the subtropics, where, for example, in the subtropical oceans, evaporation exceeds precipitation, and so this leads to very salty water in the subtropics that becomes more dense than the waters around it, and it sinks into the interior of the ocean, and it enters a subsurface pathway, but can be drawn back towards the surface by upwelling. And so those deep signals that have been transported from the tropics might reach the equatorial regions and even change hemisphere. And so in a way, that's an oceanic teleconnection that might alter the surface of the ocean in a region far from where perhaps an increased evaporation led to saltier waters being produced. So that's one example of an ocean teleconnection. But the El Nino Southern Oscillation is also an example of changes in the winds and the ocean circulation in the Eastern Pacific, leading to dramatic change in the ocean and atmosphere in the Indian Ocean, for example. So perhaps that might be another useful example.
Okay, thank you, Helen. He's asked another question, which is that what is the latest understanding of the slowing down of the Atlantic meridional overturning circulation regarding both its slowing down and tipping over into a new state?
Well, that is a wonderful question. And yes, I would be well out of my depth to try and answer that question. So I apologize. That's not something I've been keeping up on recently.
So I have a question. I actually asked this to a lot of speakers, especially since you talked about bringing in systemic change. So we've seen this across quite a few years now, where we have a group of STEM scientists who are sort of aware of the havoc that is being wreaked on our planet, and we understand to an extent what needs to be done, but not all solutions lie in technology. And as far as policy is concerned, there's another group of policymakers who may or may not be as well versed in our STEM jargon, and there's sort of like a gap between the two communication, and then there's this third issue of how to communicate it with the actual leaders of different nations. Of again, there are of course different layers of socio-economic issues in different countries. So as someone who understands this, what do you think is something that STEM scientists, and especially STEM students or young scientists such as ourselves, can do so that this gap is addressed to an extent where we can start making some tangible change into, or make a sort of dent into making some form of systemic change? Do you have any ideas on that? I'd love to hear them.
It's a wonderful question and a huge challenge, and I wish I had the answer. So I think that all we can do is to work within our networks to share information that we hold, and to engage with people across disciplines who might both bring us new understanding, but we might also help them learn more about the STEM side of things. I think it takes collaboration and patience and understanding of each other's position to try to form these conversations that will potentially bring us together. But again, I think of the another interesting book I've been reading that's from the point of view of an economist who clearly understands the threat of climate change and the impacts on the world. But I think reading more in other areas can help us see opportunities in our own situation and our own network where we might be able to expand our influence and contribute more to change. I think the IPCC is a wonderful example of taking the latest research and bringing it to policymakers. It's a very slow and arduous process, but as well as the parts of the IPCC reports that focus on the physical change, there are also those that work in the societal impacts and the mitigation and other avenues. And so that's a very broad disciplinary perspective that comes through those reports. And even just if we all read the IPCC reports, I think we would learn a lot, and we may see opportunities where we could make a difference.
Okay, thank you so much, Helen. So I think we can, with the permission of Dr. Jayakumar Sheelam and Dr. Kurian, we can move to the vote of thanks. Do you, either of you have any comments or any?
If they have any comments, Nancy Lan sir, or any one of them, if they have anything to say.
Yeah. Right. First of all, thank you, Dr. Helen, for your wonderful and insightful talk. You have given an overview of what's happening in terms of observations as well as in terms of modeling, and what is your perspective on the physical oceanography and what needs to be done also. I'm very sure that there are many youngsters who are listening to your talk, and they'll be more inspired to write to you, talk to you also. So please bear with them, and then I hope you'll get more emails. So please discuss with them if possible. And we know that India and Australia, we are well knit together on many aspects in terms of academics as well as research. We have academic collaborations between IIT Delhi and IIT Mumbai and IIT Madras with Australian universities. And we have CSIR and CSIRO as well. There are a lot of things in common. And then now President has mentioned about the different societies. I think it's high time that we have international society collaborations between OSI and other collaborations, because we are talking in terms of OSI platform. Okay, I think Aditi and Rajini, we can look into that, and you can take it forward. And then with that, I thank again Helen. Maybe I'll be in Australia next week or so. Then if possible, I'll give a call to you. Okay. Yeah, thank you very much. Yeah.
Thank you. It would be
thank you, Dr. Sheelam.
pleasure to meet you.
Okay, so I think it's time to propose the vote of thanks, and it is my privilege and honor to propose the vote of thanks for today. I would like to begin by thanking the Ocean Society of India and the Governing Council members for their coordination and support. I would like to thank the council members of OSI Pune chapter for their constant and unconditional support for any and all activities that any of our members come up with. We are always on board. Special thanks to Dr. Rajni Panchang for generously sharing her account and being there throughout to oversee the streaming, live streaming, and whatever technical issues that we came up with. She was always there. I also want to thank Dr. Gyanshilan and Dr. Supriya Chakravarti for their constant guidance and support. And most importantly, I want to thank our speaker, Dr. Helen Phillips, for an extremely inspiring and a brilliant talk we've had today, and our audience who joined both as in this meeting as well as on YouTube Live, so that this event was a success. I just want to take this opportunity to encourage any and all professionals working in the field of oceanography, and especially students, to please join the Ocean Society of India. We have life membership, we have student memberships. There are details present on our website. We'll be sure to put down the website link in the YouTube channel. So please take this opportunity to join. We want more members. We want this community to grow, and we look forward to having you join the community. And we hope to see you all next time for another webinar. We hope to continue doing this on a regular basis. So thank you so much to everyone. Thank you, Dr. Helen. And
Jayakumar sir has raised his hand.
Yes, Dr. Jayakumar.
No, just to correct Aditi, we only have one membership. That's only life membership.
Okay.
We don't have student membership.
All right. Life membership. But irrespective, I am requesting all the students, especially all the students that have joined, please do join the Ocean Society of India. It is a wonderful community. It's a wonderful team to be a part of, and we have so many events and so many coordinated activities that happen. So please take this opportunity to join. So thank you everyone, and thank you Helen for giving us your time and effort and energy. I loved your talk. We hope to have you soon sometime, and hopefully you can speak to our department students as well. I'm always looking for ways to encourage them to take up stick to the field and work in oceanography. So would love to have you again. Thank you so much.
Thank you very much. It's been a pleasure.
Thank you.
Thank you.
Thank you.
Thank you.
Yes.
Thank you, Dr. Helen.